So let's look at Anova. The AN is analysis, the O is off, and the VA is variance. So we'll be looking at analysis of variance. What do we use Anova for? We use Anova to analyze the total variation in the dependent variable. To better understand this, we will look at it from three perspectives: the total sum of squares, the regression sum of squares, and the sum of squared error. Let's get started with the total sum of squares. The total sum of squares explains the total variation in y. The regression sum of squares explains the explained variation in y. And the sum of square error looks at the unexplained variation in y. So let's get started with that of the total sum of squares. So there's this formula that people typically would struggle with when it comes to the total sum of squares, and the way I remember is this: AMP, so A, actual y, that's just y alone, mean of y, that's M, that's mean bar, then predicted y, it comes with a cap. So for total sum of squares, I see that as AM. Regression sum of squares, that is PM. That's more or less like saying in the afternoon. Then for sum of squared error, then that would be AP. So AM, that's basically saying the summation of y, which is A, y is actual, minus the mean, which is M squared. That's what we call the total sum of squares. The regression sum of squares, that's PM, that will be summation of the predicted, and the predicted is this, the y with the bar, minus the mean of y, and that's this here, we have it here, then you square it. Then we have the sum of squared error. For the sum of squared error, it is summation of the actual is this, minus the predicted y, all squared. So I'm sure we agree with this. I'm sure we agreed with this. And I'm sure we agree with this. So just for us to remember what I just said, that's this here, as a quick summary in case you need to write it down. I guess we can move on. Still on Anova, that's analysis of variance. Total variation is equals to explained variation plus unexplained variation. The unexplained variation is also known as residual variation. Still on our Anova table, let's look at regression. That's under source. The degree of freedom for the regression is K. K is the number of independent variables. From this model, we can see that we have two independent variables. So our K from this model is 2. The residual, that's the unexplained. The better way to remember residual is N minus K minus 1. So our residual is N minus K minus 1. Let's imagine that our N is 20. But we can explain 2 out of the 20 already. That's the 2 being contributed from the independent variables. That's minus 2. There's still one that we can explain that we are yet to account for, and that's the intercept, which is why we have minus 1. So the degree of freedom of the residual is basically 20 minus 2 minus 1. From here, it will be 17. If you add K plus N minus K minus 1, that would be N minus 1. The sum of squares for the regression, that's RSS, that's regression sum of squares, in the curriculum you would see it as sum of squares regression, but I prefer to write it as regression sum of squares. So in the curriculum you could see SSR, but I prefer to write it as RSS. Sum of squares of the residual, that's SSE. Then the mean of the regression, we know that mean of anything is basically the sum, and we have the sum here all over the number. We have the number under the degree of freedom. So MRS, that's the mean of the regression, will be equals to RSS all over K. The mean of the residual, that's MSE, will be equals to SSE all over N minus K minus 1. I got that here. So let's move to F-stats. F-stats looks at the significance of all of the independent variables. From here we have x1 and x2. It looks at the significance of all collectively if they explain why y is y collectively. And our T-stat, if you still remember, only looks at individual significance. The significance of x1, significance of x2, and so on and so forth. So F-stat, what's the formula for F-stat? F-stat is MRS all over MSE. We know MRS as RSS all over K. Then for MSE, that's SSE all over N minus K minus 1. Let's make this column a bit fancy. What's RSS? If you still remember, we agreed on the previous slide that RSS is PM, the best way to remember. That's the summation of P, that's predicted Y, minus the mean of Y, squared all over K. Then for MSE, still on some slide back, we agree that you can easily remember with AP, that's the summation of actual Y, that's A, minus the P predicted Y squared all over N minus K minus 1. Moving to the sum of squares for the total. That's TSS. You could see it as sum of squares total in the curriculum. That is RSS plus SSE. So we are just adding these two together. Then if you want to calculate the mean squares of the total, pretty much easy, even though we are typically not interested in it. That will be TSS all over N minus 1. What's TSS? That's AM, if you still remember. That's actual Y minus mean of Y squared all over N minus 1. So this is our Anova table, and this should make life much more easy. So I guess I've done some magic. So to remember all the magical calculation I've done, I have a summary for us here. And for those of us struggling with what N is, what K is, I have it here for us. And for F-stats, I already explained it, and I'm sure we should be fine with this. I guess we can move on.